We will now discuss the different methods by which heat energy gets transferred from one place to another. What are the different methods of heat transfer? Thermal energy gets transferred from one place to another mainly by conduction, convection, and radiation. Let's take one at a time and talk about them. What is conduction? To conduct. Suppose I have a box of chocolate in the classroom and I want to distribute it to my students. I can take one chocolate and give it to the student next to me, and that student will pass it on to his next student, and like that it will get passed on from student to student until it reaches the very end of the class. And I can distribute the whole box of chocolate to the students in the class like that. In the same way, heat energy gets passed on from molecules and atoms in a conductor until it reaches the other end of the conductor. So conduction is a mode of heat transfer within an object due to the interaction between atoms and molecules without involving their bodily motion. In the classroom, nobody walks and picks a piece of chocolate. It's an interaction among the students, just get passed on from one to the other. Conduction in metals is specially assisted by motion of electrons which carry thermal energy from one place, one part of the conductor to the other. In fact, the theory of conduction involving the motion of electrons is a little more complicated, and we will not get into there in this course. As energy gets passed on from molecule to molecule or atom to atom, heat travels progressively from one end of the conductor to the other, and that's the reason why a spoon in a hot coffee, the end of the spoon gets hot. Is that right? Heat flows from the coffee to the spoon. All right, let's talk about conduction a little more detail. The figure shows a section of a conductor of length delta x. I have shown another section here. This is the length delta x. The temperature at one end is theta 1 and the temperature at the other end is theta 2. The area of cross-section of the conductor is A. Now, what is the drop in temperature between the ends of the conductor? This end is at a high temperature theta 1, the other end is at a low temperature theta 2, so that heat flows from the hot end to the cold end. Now, what is the drop in temperature? The drop in temperature is theta 1 minus theta 2. Now, this drop in temperature occurs along a length delta x. So we're now going to define an important term in conduction. That is the temperature gradient. What is the meaning of a gradient? That's a common thing that you come across in calculus, is that right? Gradient is the slope. What does the slope mean? It's the rate of change. What is the temperature gradient? The temperature gradient is the drop in temperature per unit length, the rate at which the temperature drops along the length of the conductor. So temperature gradient is a measure of the drop in temperature per unit length. In other words, it is theta 1 minus theta 2 divided by delta x. And we write it like this: delta theta divided by delta x. The change in temperature divided by the length. This is a measure of the drop in temperature. Of course, delta theta is theta 2 minus theta 1. Now tell me, what are the factors on which the rate of flow of heat along a conductor depend on? Now, heat will flow faster if the two ends of a conductor are at two different temperatures. Is that right? If the temperature difference is high, heat will flow at a faster rate. In the same way as if the height difference, the water will flow much faster if the height difference is very high. In the same way, if the temperature difference is very high, the heat will flow along a conductor much faster. Also, the amount of heat flow depends on the area across which the heat travels. So putting these together, we can make this statement. The rate of flow of heat in a conductor is directly proportional to the area of cross-section. Greater is the area of cross-section, greater will be the amount of heat that crosses it. So the rate of flow of heat is directly proportional to the area of cross-section A, and also it is directly proportional to the temperature gradient. Now, how will you write it as a mathematical equation? Can you write this as a mathematical equation? Yes. The rate of flow of heat, don't confuse between the two rates. The rate of flow of heat is the amount of heat that flows per unit time. And temperature gradient is the drop in temperature per unit length. The rate of flow of heat, you can actually call it the thermal current. What is the meaning of a current? You see, current is formed by anything that flows. When air flows, there is air current. When water flows, there is water current. Current is the rate of flow. The rate of flow of heat, called the thermal current, is directly proportional to the area of cross-section and the temperature gradient. Now that means I can replace the proportionality sign by using an equal sign, adding a constant. So delta Q by delta T, what did we say we call this quantity? The thermal current, equal to Ka delta theta by delta X. What did we say we call delta theta by delta X? The temperature gradient. Now, this constant K is called the thermal conductivity of the material. So, the rate of flow of heat equal to K, the constant, times the area of cross-section, times the temperature gradient. K is the constant of proportionality and is called the thermal conductivity of the material. That means every conductor or every material has a value of K, the thermal conductivity. Now, K is measured in a unit called watt per meter per Kelvin. Now, how did this unit come? What is the unit of this quantity, delta Q divided by delta T? We call the thermal current. What is the unit of measuring heat? Heat is a form of energy. So delta Q is measured in joules. Delta Q by delta T is measured in joules per second. Joules per second is called watt, isn't it? So this is watt per meter. If you look at this, A has the unit of square meter. Delta X is measured in meter. So square meter divided by meter is a meter, and delta theta is Kelvin. So the unit of K is watt per meter per Kelvin. Now here I have given you some values of the thermal conductivities of some common materials. Aluminum has a thermal conductivity of 237 watt per meter per Kelvin, whereas air has a thermal conductivity of 0.026 watt per meter per Kelvin. So we say aluminum is a good conductor, or silver. Look at that, the value for silver, 429 watt per meter Kelvin. So silver is a very good conductor, whereas air is a very bad conductor. So we say air is a good insulator. See that? So you have good insulators and good conductors. The values of K will be useful as we move on to solve problems. Alright, so this is the equation we discussed earlier. The rate of flow of heat, the thermal current, equal to Ka delta theta by delta x. Delta Q by delta T is called the thermal current, and we will represent it by the letter I, the uppercase I. Now, the thermal current is measured in what? Joules per second. And so, we can now rewrite this equation, I equal to Ka delta theta by delta x. Okay. Now that means I can now write an equation for delta theta. What does delta theta stands for? The temperature difference. Now remember, it is the temperature difference that makes it possible for the heat to flow. The thermal current exists because of the temperature difference. So let's write an equation for that temperature difference. It is the temperature difference that makes the current possible. Delta theta equal to I times delta x divided by Ka. I hope you can understand these transformation of equations. Delta theta equal to I times delta x divided by Ka, and I wrote it like this, I times delta x divided by Ka. And I colored this delta x divided by Ka because it is a very important quantity. This quantity is called the thermal resistance of the material, and I represented that by R. So delta theta equal to I times R, where I is called the thermal current, that is delta Q by delta T, and R is called the thermal resistance, delta X divided by Ka. Alright, so that's our equation. R equal to delta X divided by Ka is called the thermal resistance of the material. And what is the unit for measuring R? R is measured in Kelvin per watt. Kelvin per watt. I want you to use the units of delta X, A and K and see how you get the unit of R as Kelvin per watt. Now look at this quantity. Delta X divided by K. This has a special significance. Delta X divided by K is called the R value of the material. Now, if you go to Home Depot to buy some insulating materials, now we use a lot of insulating materials when you build our homes, is that right? If you go to Home Depot to buy an insulating materials, it is rated for its R value. So notice that the R value is not the same as the thermal resistance. The thermal resistance is delta X divided by Ka, whereas the R value is simply delta X divided by K. In building industry, the insulating materials are classified using their R values in their ability to be a good insulator, in their ability to allow heat to pass through. That is the R value.